welcome to True Projects. In this video, we are going to explain the project Online Digital Check Clearance and Verification System using blockchain. Introduction. The project aims to revolutionize the conventional check processing methods. Traditional check processing relying on physical paper checks and manual data entry is criticized for its low speed, error-prone nature and opacity in financial transactions, which can lead to fraudulent activities. To address these shortcomings, we are incorporating blockchain technology. Blockchain functions as a digital ledger, organizing transactions into blocks to establish a secure and transparent data chain. Blockchain has several advantages. It is decentralized, which means there is no one person or organization in charge, making it resistant to manipulation. Transactions are transparent so everyone can see them. It is also secure due to strong encryption. It accelerates encryption-decryption processing time, and once data is added, it is nearly impossible to change. There are many types of blockchains such as Ethereum, Bitcoin, Stellar, Ripple, etc. Each has its unique features, governance models, and target use cases. We are using Ethereum in this project. Ethereum goes beyond just recording transactions. It allows developers to create small computer programs called smart contracts. These smart contracts, without the need for a centralized authority, a legal framework, enable trusted transactions made between anonymous parties. Ethereum's strengths include its ability to create various decentralized applications and its active community of developers. It continuously improves its security, and many other projects in the blockchain space work well with Ethereum. Therefore, this approach leads to faster, more safer and transparent check transactions, building trust and enhancing efficiency in banking. Objective of the project. The aim is to streamline and accelerate the time-consuming process of traditional check handling. By digitizing checks, that is, transforming physical checks into digital assets and using modern technology, we aim to significantly decrease the time it takes to process them. We aim to enhance fraud detection in check processing by verifying signatures and employing advanced fraud detection mechanisms. Instead of OCR, we are using MICR, that is magnetic ink character recognition, for signature verification due to varying handwriting styles. And the objective also includes developing a user-friendly web interface using Django, a web framework. This interface will facilitate user interactions, making it easier for users to submit and track check transactions. And we also aim to employ blockchain technology and smart contracts to ensure the security and efficiency of the check processing system. Requirements needed to execute this project are hardware requirements: processor of i5 and above, RAM of 8GB and above, ROM of 25GB and above. Software requirements needed are Node.js, Python 3.7.0 and Visual Studio Community version. To execute the project, we have designed few modules. The first module is New User Sign Up. New users can create their accounts by providing their personal information and uploading a signature template for future verification. Security measures like authentication and encryption are in place to protect user data. The second module is User Login. Registered users can log in using their usernames and passwords. The system ensures the confidentiality of login credentials through secure communication protocols. The third module is Digitize the Check. Users can submit checks for processing. The system uses image scanning to convert physical checks into digital format. User uploaded signature templates serve as reference for verification, and MICR technique ensures accurate signature verification. Once verified, check details are securely stored in the blockchain using smart contracts and encryption. The next module is View Credited Checks. Users can see information about checks credited to their accounts. This data is retrieved from the blockchain using secure methods with user authentication for data privacy. And the last module is View Debited Checks. Similar to the previous module, users can access information about checks they have issued and debited from their accounts. Check data is retrieved securely from the blockchain, maintaining confidentiality and security. Blockchain integration. Blockchain is used to securely store digital check instances. When a user submits a check, it is stored in the blockchain through encryption, safeguarding sensitive check data. It securely stores user details, making them tamper-proof and easily accessible. The smart contracts in Solidity streamline the check clearance process, such as decryption and verification of check signatures and details. Once validated, The smart contract triggers a secure transaction to credit the specified amount to the recipient's account, ensuring the entire process is efficiently recorded on the blockchain. And data integrity is maintained in the system through the utilization of the SHA-256 algorithm, that is Secure Hash Algorithm 256-bit. Each block in a blockchain is linked with a unique hash code. These blocks are maintained across multiple nodes or servers. Before storing new records, blockchain verifies the hash code of each block. If any block data is modified, it results in a different hash code, triggering security alarms and ensuring the integrity and immutability of the data. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is checks folder, in which I have images of checks which will be used in the application later. This is digital check folder. Inside this folder are Python code files that are intended to be dynamically loaded into the project during runtime. This is digital check app folder. This folder comprises a static folder which contains files related to CSS, JavaScript and Bootstrap. These files contribute to the visual and interactive aspects of the application. Digital check app folder also contains a templates folder. Within this folder, we'll find all the HTML pages used throughout the project. It includes pages like index.html, home.html and more, representing various sections of the website. And it also contains Python code files that will be executed during the runtime of the application, supporting its functionality. This is Hello It folder. Inside this folder, I have a node modules folder. This folder consists of dependencies or modules needed for the project. Open.bin folder. This folder often contains executable scripts related to the project's dependencies. So we have to run blockchain.bat file. Double click on it to start the blockchain. This script will initiate the local Ethereum blockchain for development purposes. It contains commands to start the blockchain environment. Now the blockchain is hosted on the local machine at the local host and the port. This address allows us to interact with the blockchain using various tools and applications. Now, execute the command truffle space migrate to compile and deploy the smart contracts. I'm typing truffle space migrate and hit the enter button. Truffle is a development framework for Ethereum that simplifies the process of compiling and deploying smart contracts. They are deployed on a blockchain network and can facilitate various transactions such as transferring tokens or managing digital assets. Once the migration process is complete, Truffle will provide us with a unique Ethereum contract address. This is the address. This address represents the location of the deployed smart contract on the blockchain. And here we can see gas used. To execute the check solidity file and compile smart contracts, this is the amount of gas used. Now minimize this. This is the templates folder, in which I have images of signatures which will be used in the application later. This is check file. This file consists of Solidity code. Solidity, the language of Ethereum smart contracts, enables self-executing programs. It handles data structures, functions, and events with modifiers for validation. This is manage.py file. It is a command line utility that comes with Django. It provides various commands for managing Django projects, including tasks like running the development server, creating database tables, applying migrations, and more. And this is run.bat file. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. Double click on it to start the Django application. So the Django framework will host the application locally at the default address localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, type index.html at the end and hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using the Django framework. And here we can see user login and new user sign up links. Click on new user sign up link. So if you are new users, we have to register first. Fill in all these details and click on register to sign up. So I'm giving the username as Ravi. Give the password. Give the contact number. Give the email ID. Give the address. And we have to choose the signature image. Click on choose file. So from templates folder, I'm selecting the first signature and click on open. Now click on register. So in red color text, we can see sign up process completed and record saved in blockchain. We will create another account. The username would be Raju. Give the password. Give the contact number. Give the email ID. Give the address. Choose the signature image. Click on choose file. I'm selecting the second signature and click on open. Now click on register. So we can see sign up process completed and record saved in blockchain. Now we will log in. Click on user login. We'll log in as Ravi. Give the username and password of Ravi. And click on login. So here we can see welcome Ravi, and we can see digitize your check, view credited checks, view debited checks and logout links. Click on digitize your check link. So fill in all these details. Receiver name would be Raju. Upload the check image here. Click on choose file. So from checks folder, earlier we registered the first signature. Now we have to select the first check since the signature matches. And click on open. And now enter the check amount. I'm giving it as 10,000. And click on verify and deposit check. So here we can see your check successfully digitized and credited to receiver Raju. Now click on view credited checks. There are no credited checks, the received checks. Click on view debited checks. So here we can see the debited checks, the issued checks. We can see sender name, receiver name, amount and transaction date details. Now click on logout. Now we will log in as Raju. Click on user login and give the credentials of Raju. And click on login. So here we can see welcome Raju. Click on view credited checks. So here we can see credited checks, the received checks. We can see sender name, amount, transaction date also. Now we will try digitizing a different check with a signature that doesn't match. Click on digitize your check. So the receiver name would be Ravi. So we have to upload the check image. Click on choose file. I have registered with second signature, so I have to give the second check here, but I'll try giving first one and click on open. So enter the check amount. I'm giving it as 10,000. Now click on verify and deposit check. So here we can see fraud check detected. So the system has flagged it as a fraudulent check. Now click on logout. So the conclusion here is the project aspired to transform conventional check processing by implementing cutting-edge technologies like blockchain and smart contracts. It successfully implemented signature verification using MICR, that is magnetic ink character recognition, that identifies and validates signatures on checks by recognizing the unique magnetic ink patterns, ensuring the authenticity and security of the transaction. It notably decreased check processing duration while simultaneously boosting security and accuracy in verification, making substantial improvements in the efficiency and reliability of the process. This project is beneficial to banks, businesses, and individuals as it enhances the efficiency, security, and transparency of check transactions, meeting the needs of all stakeholders involved. Therefore, the project demonstrates how blockchain can change finance for the better, making future financial transactions safer and more efficient.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.